All right, let's look at how you do percent composition. So when we talk percent composition, we're talking what percent an element is of a compound by mass. And what this means is you look at a compound like this ethanol right here, and we're going to say what percent out of the mass of the entire molecule would just the carbon be, or what percent would just the hydrogen be out of the entire mass, or what percent would just the oxygen. So in order to do that, we have to do is we deal with anything in this unit, we have to do conversions involving moles. So here's the idea. We're going to say the mass of one individual atom is way too small to measure. It's way too hard to deal with, so it's easy to do with the mass of an entire mole of atoms. I mean, after all, that information can be found on the periodic table. So that is done by, well, a couple of things. First of all, we're going to look at 1 mole of the molecule. We're going to say, look, 1 mole of this molecule contains 2 moles of carbon, 6 moles of hydrogen, 1 mole of oxygen. So we're going to then take that and say, look, that 1 mole of that 2 moles of carbon, we're going to see what percent of mass. We're going to compare the mass of 2 moles of carbon to the mass of the entire mole of the entire molecule. So 2 moles of carbon, again from here, convert it from moles to grams, find out what mass those 2 moles of carbon would be. We do the same thing for the other elements. So there's the mass of 6 moles of hydrogen, right? 6 moles of hydrogen converted to grams, there's a mass. Or 1 mole of oxygen converted to grams, there's a mass. So once we have that, we're going to compare the mass of just the element to the mass of the entire molecule. So that means you've got to grab the periodic table and use it to figure out what's the mass of the entire molecule. Well, that's the mass of 2 carbons plus 6 hydrogens plus 1 oxygen off of here. In other words, you just add these together. So that gives you the entire mass of the entire molecule. Or I should say the entire mass of a mole of the entire molecules. So the way you find the percentage is you're going to say, look, in each molecule, a mole of the molecule is this much, and inside that mole there's 2 moles of carbon, which weighs this much, as calculated on the previous slide. So we're going to find what percent this is out of the total. So the mass of the carbon divided by the total mass. This is the decimal that comes when this is divided by this, and you convert that decimal to a percentage by moving the decimal 1, 2 decimal places. Essentially, this is times it by 100. And when you times it by 100, I should make clear that, okay, so you take the decimal, times it by 100, and that will give you the percentage, which is that percent right there. So that tells you that out of the mass of the entire molecule, 52.15% is carbon. So we do the same thing with the others. The mass of hydrogen was calculated to be this. So we divide it by the total, and that gives that decimal, which is that percentage. And that would be the answer for a percentage of hydrogen. We do the same thing for the other ones too. Mass of oxygen divided by total gives percentage oxygen, or the decimal form of this percentage oxygen. So that's what when we say the percent composition, this is what we're looking for, the percent that each element represents out of the entire molecule. And if you add these up, they should come close to 100%, but maybe not quite just because of rounding issues. So one last thing, obviously you want to make sure to actually box these, and so you probably just want to box them all in one place. Why is it 4 significant figures for these? It's because of the numbers used. More specifically, these calculations come from here, and these calculations, and you can bring it back to the previous slide, come from here. And you'll notice that we're going to say this is infinite significant figures because it's exactly 2. So we're not going to worry about these numbers that you pull out of a formula. We're not going to worry about this number right here. It's the molar masses that determine your significant figures. So 4 sig figs, 5 sig figs, 4 sig figs, 4 sig figs, 4 sig figs, right here. So all these are going to represent that. Now technically it is true that you should not round these until the end, which means technically I shouldn't be worried about these being 4 significant figures, but here's the thing. The calculation does involve this, which should be rounded to the hundreds place. This is 4 significant figures. All of these involve this 4 sig fig number. So it's actually this that is the reason why all the answers have 4 significant figures. And so that would be the reason for the rounding like that. So that should cover that in terms of the percent composition. I think that, and so I think all the other practice ones go along the same lines as that. So there we go. That should take care of it.